let's go through these 30 multiple choice questions as kind of a review of the concepts a little bit. And we'll post the questions on Edmodo tonight. And so like tomorrow, if you look at them and have any questions, you can come in and ask me about those. Alright, number 1. If you know the wavelength of any form of electromagnetic radiation, you can determine its frequency because. What's the relationship between frequency and wavelength? Anybody remember that equation? C equals F lambda. Alright, so let's look at the quick choices here. All wavelengths travel at the same speed.
That's not true.
That is true.
True.
Okay, so
Sound waves will travel the same speed as light waves. The answer's A. Alright.
talking about light though. Quiet guys. Alright, so if C stays the same, and we know lambda, then we can figure out F. Does that make sense to everybody? So the answer is A. And speed of light does not vary for each form. It stays the same. Wavelength and frequency are equal. They're not equal. Speed of light increases as the wavelength increases. Again, not true. Alright, number 2.
That's automatic.
When incoming light rays strike a flat mirror at an angle close to the surface of the mirror, the reflected rays are... What is the angle of incidence equal? Angle of reflection. So what should the answer be here?
C.
Not C. If they come in close to the mirror surface, they're going to be reflected close to the mirror surface because the angle of incidence equals the angle of reflection. Does that make sense to everybody? Number 2 is D.
What was 1 again?
1 was A. Number 3. Which best describes the image of a concave mirror when the object at a distance is greater than twice the focal distance of the mirror? Okay, so we can do this one with our diagrams, or we can do it with math. It's a little easier to do it with math, I think, in these. So you have a concave mirror. So does a concave mirror have a positive focal length or negative focal length?
Positive.
Positive. So let's say it's 10 centimeters for the focal length. 1 over image distance plus, it says it is greater than twice the distance from the focal point, so let's say it's 1 over 30. So I just made up those numbers. Does everybody make sense to why they match everything else? Alright, so when we subtract this from this, is that going to be a positive number or a negative number?
Positive.
Positive, so that means DI is positive. So what does that mean about the image?
Real.
Real. Does that make sense to everybody? And we do magnification is equal to negative DI over DO. And is that going to be positive or negative?
Negative.
Negative. What does that mean?
Inverted.
Inverted. Does that give us enough information to answer this question?
No. You didn't have to figure that out.
You need to figure out the magnification as well. So, if it's real and inverted, now let's just do it. So what is 30 minus, what's 1/30th minus 1/10? 115. So DI is going to equal 15 centimeters. So is 15 over 30 greater or less than 1? Less than 1, so what is it going to be? Smaller. Does that make sense? So you can do that without, use the equation to figure that out? So that was number 3. So you can always make up numbers for those kind of things if you don't remember what the actual answer is supposed to be. Alright, number 4. A parabolic mirror instead of a spherical mirror can be used to reduce the occurrence of which effect? This is kind of from the notes. Anybody remember this? Spherical aberration. So that was A. Number 5. Which of the following is not an additive primary color?
Yellow.
That is correct, Michael.
What?
That was number 4.
4 was A. So 5 is A as well. Remember the additive primary colors, the colors of light that combine to form white light, are red, blue, and green. Those are the ones that if you look at your TV really closely, that's what you see. Number 6. Which is an example of refraction? A parabolic mirror in a headlight focuses the light into a beam. A fish appears closer to the surface of the water when it's really observed, or when it's observed from a riverbank. In a mirror, when you lift your right arm, your left arm, or your image is raised, light is bent slightly around corners. B. The fish in the riverbank. Number 7. The blank of light can change when the light is refracted because the velocity changes. So the velocity is equal to frequency times wavelength. So one of those is going to change when it slows down. Does anybody remember which one? Wavelength changes. So it's C. Okay. What happened? What you want to think about here is when it slows down. Think about if you had like water waves coming toward the beach and they started to slow down. What would happen? Would they get closer together or farther apart? Closer together. That's what happens to waves when they slow down, or in light waves when they slow down too. So the wavelength shrinks when it slows down. Make sense, everybody? I should remember my camera. That was probably really goofy. All right. Number 8. Carbon tetrachloride is poured into a glass container made of crown glass. If a light ray in the glass is incident at the glass to liquid boundary and makes an angle of 30 degrees with normal, what is the angle of the corresponding refracted ray? Anybody remember what equation we used to solve for this one?
N1 sine.
Yep.
Equals n cosine theta.
N1 sine theta 1 equals N2
Sine
sine.
You misspelled sine. There you go.
But you spelled sine. Right?
Alright. So the substitute numbers in. What's N1 for this one?
1.46.
What's our angle of incidence?
30.
30.
What is the second material it goes into?
1.52.
We do sine 2. And the answer is
D.
C, 31.4.
Seems reversed that.
Okay. So don't hold that one slide. That's math.
Okay, did you guys all do that one? Alright. Number 9. What type of image does a converging lens produce?
Virtual.
Is it real, virtual, or both? Or can it produce either? Think about the diagrams you drew.
It's D. No, wait, no.
None of these. Right.
Well, it could not be an image.
I just drew in my head. Alright, so think about the drawings we did. Converging lens, the one like this. Is that the one we drew a whole bunch for, or just like 1 or 2 for?
2. Whole bunch.
Whole bunch. So what do you think the answer is? C. Real or virtual for converging. So converging lens and concave mirror can be real or virtual. Diverging lens and convex mirror are always virtual. Right. Number 10. In what direction does a parallel wave from an object proceed after passing through a diverging lens? So is a diverging one focused onto a point or spread it out? Spread it out. So the ray passes through the center of curvature C, is that correct? No. The ray continues parallel to the principal axis. Is that correct? No, it gets bent. The ray passes through the center of the lens. No. The ray is directed away from the focal point at F. That's correct. So it goes away from the focal point.
So I got through the first 2 choices.
Alright. Number 11. The focal length for a diverging lens is... Anybody remember this from the sheet?
F to the negative.
What?
Negative.
Negative. So focal length for a diverging lens is always negative. Converging lens is always positive. Which type of mirror is negative? Concave or convex?
Convex.
Convex and concave is positive. So basically anything that spreads the light out, the focal length is negative. Anything that focuses the light onto a point, the focal length is positive. Number 12. Which is not correct when describing the formation of rainbows? So rainbow, it is really spherical in nature. You can only see a slice of the sphere though.
D.
D. All wavelengths do not refract at the same angle. If they refract at the same angle, the colors wouldn't separate. You wouldn't see the rainbow. Okay. Number 13. This is the diffraction experiment we did, or the diffraction problems we did. So this is double slit experiment. The center of the pattern is E, so that's a bright spot. F is a dark spot. G is a bright spot. H is a dark spot. I is a bright spot. Everybody kind of understand what that means? The bright and dark. So the dark spots are actually dark spots here. Okay. I'll write the equation up here. So the equation for this is D sine theta equals m times lambda. Alright, what it says here, if the two slits are moved closer, which of the following would occur in the pattern? So, if we move the slits closer, what variable is going to change? D. So I'm going to solve this out for sine theta equals m lambda over D. So if theta increases, the things are going to get further apart and move down this way. If it decreases, they're going to get closer together. Does that make sense?
Yeah.
So if D decreases, what happens to theta?
Decrease. Increase. Decrease.
Kara, your calculator. Kara,
Yeah.
somebody. Take the inverse sine of 0.9 and the inverse sine of 0.5.
0.9 and 0.5.
Yep. Which one's bigger?
0.9.
0.9 is bigger, so if this side gets bigger when D decreases, right, that means theta is going to get bigger. So the inverse sine of something, as whenever you're taking the inverse sine of increases, the angle increases as well. So our angle is increasing, so let's look at the answers here. E is not going to move because it's the center one. So would F shift to the right or to the left if the angle increased? So E is the center, right.
Yes.
So the answer is C. Does that make sense, everybody?
Yeah.
Okay. Number 14, the distance between two slits in a double slit interference experiment is 0.04 millimeters. The second order bright fringe, m equals 2, is measured on the screen at an angle of 2.2 degrees from a central maximum. What is the wavelength of the light? Alright, so what's our distance?
0.040.
You gotta convert it to meters, so it's gonna be 0. I had too many zeros. Yeah. And sine, what's our angle?
2.2 degrees.
Equals, what's m?
2.
2, we're looking for wavelength. So our wavelength should equal 7.7 times 10 to the negative 7th meters, or 770 nanometers D. Any questions, anything from that first page? Is this all sounding familiar to you guys?
I wouldn't say familiar, but
Something? It will be familiar soon, hopefully. No. Alright,
tired.
number 15. Monochromatic light shines on the surface of a diffraction grating with 5.3 times 10 to the third lines per centimeter. The first order maximum observed at an angle of 17 degrees. Find the wavelength. Alright, same equation. Finding D is tricky here, because we have to do D equals 1 over 5.3 times 10 to the third, and that's lines per centimeter. What is that answer?
Uh,
10 to the third.
1.1.1 .89 times 10 to the negative 4. Is that right?
Yep.
Okay.
The distance between the lines in centimeters.
Wait, that's
Okay.
1 over that equals
And then, somebody wants to double check if they can. We gotta convert this to meters, so we end up with 1.89 times 10 to the negative 6 meters. To make your life easier, you can convert either place, but it's much easier to convert after you convert it to centimeters. Does that make sense? Or after you've gotten it just in centimeters. So do the 1 over thing, then convert to meters. Everybody understand that? So now we do 1.86 times 10 to the negative 6 meters. And sine, what's the angle?
17.
17 degrees equals, what's m? So lambda should equal 5.5 times 550 nanometers. And how do we get from nanometers to meters? So
Divide by
10 to the
9.
nanometers to meters, you divide by 10 to the 9th. Meters to nanometers, you multiply by 10 to the 9th. Alright, number 16 is the same problem. I don't know why I put, or 16 and 17 are both the same problem. I'm just going to tell you guys the answers to that. Does anybody want to go over those? Okay. Does anybody want to do anything? Just thought I'd check.
It's so hard. My question, like getting out of bed, like it's not like in bed and go to school.
I really am interested in what
Okay, outside of getting cookies.
Cookies?
Alright,
Elena, cookies?
I'll pay attention.
Let's just have a face.
quiet guys. Alright, so number 16 is A, and number 17 is B. Yay.
Spells app.
Yeah.
You guys are
It's not all of us.
mainly you. Okay, number 18. The color of an object we see is determined by
E.
E, all the above. What matters for the color of the object we see is what colors of light it reflects, what colors of light it absorbs, and the colors of light is either determined by frequency and wavelength. Questions on that one? Or 19. Different colors of light correspond to different light
Frequency.
Hey,
frequencies. A.
That's what the judge.
Number 20. So frequency determines what color light is. 20. The reason the sky is blue is that air molecules D absorb and then re-emit blue light, scattering it in all directions. Alright, 21. Three primaries of colors of light for additive color mixing are
E.
it is E.
no, it's not E.
Told you.
A, red, blue, and green.
Wait, that's the one that we have.
Is the same? That's the not the same question, but the same idea. Number 22. When red and blue light shine on a white sheet, the resulting color is
Yellow.
E, magenta.
Wait.
What makes yellow?
Green. Yellow and blue. Red and green.
Red and green make yellow.
What makes yellow?
Okay, blue and red make magenta. Red and green make yellow, and blue and green make cyan for light. 23. A converging lens.
E.
It is all the above. It converges parallel light rays, so it takes all the parallel light rays, put them on the same point. But all lenses refract light. Converging lens is thicker in the middle. Diverging is thinner in the middle. And bends parallel light rays so they cross at a single point. Alright, number 24. An image formed by a single diverging lens is...
E.
No.
Upside down.
Okay,
Virtual. Why would it be on? Gotta be one.
alright. So is the focal length for a diverging lens positive or negative? Negative. So let's say it's negative. Give me a number.
54. first number that came
Alright,
up.
so negative 54 for our focal length. The image distance is going to be what we're trying to find here. Where should the object be? How far away?
10.
Okay. What does di have to be here? Negative. Di. Does everybody understand why di has to be negative? We have a negative number and we're subtracting something from it. So, can you get a real image with a diverging lens? No. Is that enough for our answer?
No.
That means it has to be virtual, so 24, the answer is C. Let's finish going through this though. For magnification, we have negative and a negative di. So what does the magnification have to be? Positive, so that means it's virtual, upright. And it's also smaller because when you subtract this from that, or you end up adding those two together, so this is always bigger than do. Or sorry, do is always bigger than di. Questions about that? So diverging lens, always virtual, upright, and smaller. Alright. Number 25. If an object is located inside the focal length of a converging lens, the image will be so is a converging lens the focal length positive or negative? Positive. So give me a focal length for a converging lens.
24.
We're at 24. 1 over di. What's our
42.
8.
It's inside the focal length, is that right? That's all it says? So let's say 8. I keep making other equals. Alright. So, is di going to be positive or negative? Is 1/8 or 1/24 bigger?
1/8.
So we end up with a negative di. Make sense? So, that means it's virtual. Is that enough to answer our question? You're good. Nope. We need our magnification. The magnification is negative. We have negative di or do. So what's our magnification? Positive. What does that mean? Upright. That's enough to answer our question. So it's right side up. So 25 is A. Shelly?
Couldn't, since you're picking any number, like, couldn't it come out positive if the focal length is?
Well, it says it's inside the focal length. So this number, so DO is smaller than F. That means it has to be negative. Does that make sense?
Bigger than that. So it's smaller.
Well, the fraction is bigger than F, but the actual number, like the object distance is smaller than the focal length.
So if it's inside the focal length, DO has to be larger. No.
So like, let me draw the diagram for you. Is this a mirror or lens?
I don't know. Lens.
Lens. So like, here's F, here's where our object would be. Does that make sense? So this in this case would be 24, that would be 8.
Okay.
Does that make sense why it's inside the focal length and why the... So it doesn't matter what numbers you use for that, if you use, as long as DO is smaller than F, because
Okay.
that's what it's saying. Alright, number 26, electromagnetic waves need a medium to travel through,
No.
or cannot travel through a vacuum, or can travel through a vacuum.
Speed.
It's B. Electromagnetic waves can travel through a vacuum, otherwise Earth would be a cold, lonely place because no light would ever get here from the sun. Alright, 27. Which of the following is not an electromagnetic wave? A. Sound is not an electromagnetic wave. Good job, Michael. Number 28. The primary purpose of polarized sunglasses is
D.
to... It's not going to work for you no matter how cool the sunglasses are, Michael.
Wow.
It is C, to block glare from reflection. Remember we used those polarized filters, you've looked at the desk, you couldn't see the reflection as well. That's because light that's reflected is polarized horizontally, and the polarized sunglasses are polarized vertically, so none of that reflected light gets through. Number 29, light does not pass through which kind of material?
It's not C.
It is opaque.
Oh, the definition.
Opaque is something that light does not travel through.
Are we done?
What's the other kind of material?
Translucent.
Translucent.
Let's go.